In this last lecture from the course and from Chapter 14, we will continue to explore simple linear regression. Given that we can calculate a linear regression model, there are other variables that define the extent or the goodness of that relationship. The first of these is the coefficient of determination. Similar to the sum of squares values in an ANOVA table, we can calculate three values to define the regression model. The SSR is the sum of squares due to the regressed line. SSE is the sum of squares due to error. And SST is the total of the two. We can calculate each of these values using the mean of y bar, and the predicted value of each y. The value of r squared is called the coefficient of determination, which is the sum of squares due to regression divided by the total sum of squares. For the data on the car sales and advertisement example, we calculate a coefficient of determination of 0.8772 using the formulas on the previous slide. This indicates a very strong relationship between x and y. The correlation coefficient, r, is the square root of the coefficient of determination, but with the same sign as the slope, beta sub 1. Both the coefficient of determination and the correlation coefficient measure the goodness of fit of the actual data to the regressed line. The closer either r squared or r is to the value of 1, the better the relationship. A rule of thumb is an r squared value at 0.5 or less indicates a poor or even no relationship, and an r squared value of above 0.75 indicates a reasonably good relationship, whereas an r squared value of 0.9 or higher indicates an excellent, very good fit relationship.